Hello, I'm Mike Coffey. I'm Executive Vice President at Rite Solutions, and I'm here with my colleague Tom Santos to talk about our capstone initiatives with URI. First, a little bit about Rite Solutions. We've been in business for about 20 years. We're an extremely employee-focused company. We have a culture that's called the culture of the few, friends enjoying work. Very vibrant culture that emphasizes employee satisfaction and customer satisfaction in about equal measure. We're very much oriented toward technology and the application of technology to our business areas. In particular, we work a lot in the undersea warfare domain, but also in commercial businesses and non-DoD software development. So software is a big part of our business. Information technology and cyber, those are the key areas. From a technology standpoint, the things that we've been concentrating on have to do with cybersecurity, and in particular, looking at cybersecurity from a different perspective. You all know all about the application of defensive measures in cyber, the things that keep bad actors out. We're concentrating on how to detect and remediate cyber issues from within software applications. A second area that we're looking at is the application of artificial intelligence and machine learning. And in fact, we've had a strong partnership with URI in that area. Tom's going to tell you a little bit more about that. In particular, we're not going to be inventing the next great machine learning algorithm or machine learning process or anything like that. But what we are trying to do is apply artificial intelligence and machine learning to, for example, the undersea warfare domain or any other of our business areas. So as I said, Rite Solutions, we've been here a good long time, 20 years. We're about 270 employees strong right now and growing. And we really welcome the opportunity to extend our partnership with URI on these capstone initiatives. So now I'm going to turn it over to Tom to talk a little bit about those.
Hi, thanks, Mike.
You bet.
I want to just say I'm personally very excited to be working with URI. You know, I went to graduate school there and have nothing but good memories about my experience, and we've continued to work, as Mike was saying, with URI in a couple of other areas. So today what I'm going to really talk about is the two projects that we've identified for the capstone. One happens to be in the area of object detection on the seabed. And then it is exactly what it says. We want to be able to detect things on the ocean floor. The second one has to do with ship classification. And again, both cases we use machine learning to either identify objects or to identify and classify ships. So with respect to the first one, the object detection on the seafloor, the idea there is that we're going to be extending some work that has been done already by Dr. Daniels at URI. We have an innovation voucher with them, with URI, and they're working on a new approach for object detection. And so what we're going to be doing is extending that. We want to be able to take that algorithm and, in a sense, productize or really apply it to a real-world, scenario. To do that, we need a couple of things. One, we need some simulated data, and we have to be able to generate some simulated data that's more representative of the real world. The second thing we need to do is we need to go ahead and translate some of the work that has been originally developed in software that's originally been developed in Python and TensorFlow to a new language called Rust. In the first case, we'll be using MATLAB to generate the simulated data, and in the second case, Rust, for those who don't know it, is a relatively new language, primarily used for safety, critical systems. And our thought is that this is going to be used in onboard some sort of vehicle on the water. So safety is going to be a pretty important component of whatever you do. The other thing is Rust is kind of cool in that it's an upcoming language, and it's actually going to be used for applications like the Linux kernel. So with that, you'll be working with some of our folks here. One person is a physical oceanographer. In another case, will be a senior software engineer. In the second case, we're talking, the application is ship classification. We had a project where, in the past, where we actually did ship classification using the Google Cloud AutoML capability. We classified or curated, a large data set, used that to classify ships, and the bottom line is that worked out pretty well. The problem we're trying to address, however, is that uses the cloud. In a lot of environments that we work in, we won't have access to the cloud. So as a result, we need to be able to do this in a standalone environment. So in this particular case, we want to be able to identify open source implementations of AutoML that we could use on a standalone system. The second part is that we want to specify and actually purchase an AI system that we could use locally and to train the machine learning model. That way there we won't be needing to actually go out to the cloud for anything. And the third thing, we want to be able to generate a machine learning model that we could actually put on a small device that uses a AI hardware accelerator, so that we can actually make inferences in real time. So that would take us from soup to nuts from the time that we collect the data, curate the data, and actually create the model to actually classify ships. So in that particular case, you'll be working with one person. His name is Ken Toye, and he was actually a senior. He also participated in the Senior Capstone Project a couple of years back. And also you'll be working with some of our other senior software and system engineers too. So with that, I hope you find this interesting. I hope you decide that this is something you want to do. Some of the technologies here are definitely very, very new and interesting, and just kind of cool. So with that, I thank you.
Yeah. So we look forward to seeing you over here in Middletown.